Thank you for taking time to check in and watch our webinar presentation. So I'm going to start this with an introduction and background to why we do this. Why have we started doing IP elements or camera enclosures for the industry? Talking a little bit rating and standards and some of the choices we made in materials and what you can choose when you implement different in different environments. Moisture, which we know is a killer for electronics, so we'll look a bit at that, and dirt prevention and heat management. And in all this, I will include some tips and tricks here and there, and maybe some surprises. So yeah, thank you, and here we go. So we started IP Elements in January 2020. We had done some development already then. And all this was based on frustration with existing products. I have 25 years of doing machine vision and often in rough environments. And the existing solutions didn't make me happy. They were, fiddly and not always good quality. And so I joined up with Pedro Montero, that has 20 years of years of experience of design engineering and manufacturing. And we sat down and started with a blank paper and to find a solution that fulfilled, to start with, my needs, but also others' needs as we progressed and talked to others. So this is how it started, and this is where my career in machine vision started, in iron ore mines and the refineries of iron ore, which is a very, very, very dirty industry. And here we actually used laser and camera triangulation on conveyors to measure the size of what's called pellets, or basically size of gravel on the running conveyor. And we had to resort to, standard CCTV enclosures that we fitted with special sapphire glass to make them dirt resistant and so on. So heavy dirt. Another thing is in steel mills, there we have heat. So I worked a lot with heat and handling that. And when you're very close to a hot steel slab, it's hot. We also have the opposite, cold, of course, because I'm from the far north of Sweden, where we can have down to minus 43 degrees outside. And one of the things is, for example, to check the brake pads and the connectors and so on between the carriages on iron ore trains, and try to do this outside in this environment with snow, with ice, with cold. So there we have the other end of the extreme. And also try to do it with precision. In this case, we're scanning copper anodes in 3D, and it has to be done with a high degree of precision within this rough and dirty environment. And this is just another example of presses where maintenance isn't always what is done in a degree that they should be done. So everything gets very dirty, oily, greasy, scales, and so on. And here we see some examples of this environment where we have heat, we have shock, we have vibrations, we have possibly water leaks. It's just a really nasty environment for a machine vision system. So we sat down and started thinking, what are important for an enclosure for using this? And number one, and compared with others, is easy to use. It should be easy to use. And that has been our key through all of it. When we design a new feature, how easy is it to use? That's the key. And once you hold this camera house in your hand and try to mount a camera, you will actually realize how easy it is. So this is the key. We want it to be modular so that, you know, different accessories can be fitted and different mountings, and they're stackable and they fit together with each other, and just an ecosystem of accessories that builds on each other. And we also want it to be cost effective. And one part of that is to choose materials and manufacturing methods, and you know, to produce a product that's low cost in purchase. But also, as we can see here, one important thing is serviceability. And if we can go in and keep machine times to a minimum, down times to a minimum, that is a big cost saving, and our customers will appreciate that. And, you know, as an integrator, we of course earn more money on that with happy customers. But it's a big savings in cost by having quick serviceability. And here I show you how to change a camera. And in this case, we undo the cable glands, and that's sort of a necessity. Remove the lens tube. And then we have a clamp system, as you could see in the previous video, where the camera is mounted in there. And we just undo the clamp, and then we can push out the camera. Put in a new camera. And because all this is so easy, this can also be done in a very dirty environment without taking anything down, and you know, make it easy. And one important feature here too is that the camera goes in to exactly the same point where it was before. So it makes it easy, no major recalibration afterwards. Of course, when you change anything on a vision system, you need to recalibrate. But the changes, the position changes are minimal in this case, so we can quickly get back to what was before. And we do a final tuning. So by having a tube system where the lens is accessible all the time, we can actually easily adjust focus and aperture on the lenses. And there we go. So this is part of being cost effective. And as a result of these thoughts, and what we came up was the IP Elements camera enclosure with an ecosystem of accessories. And we're going to see some of them here, but I'm also going to talk in general about machine vision in dirty environment. So first, we of course have some rating and standards and certifications. One of the most important one is the IP rating, that it actually can stand the ingress of solids and fluids. We have EX rating for explosive environments and vandalism and impact. I will not go into any depth of EX and vandalism, but just mention it and some aspects there. When the IP rating, it stands for ingress protection, and of course IP elements. There is a connection. So the first digit there is about solids. So it says the size of solids that are allowed to enter the enclosure. In our case, we always on number 6. It should be dust timed. We don't want any dust in our machine vision systems. So number 6 is where we go. So whether it's IP65, 66 or 69K. The second digit is about liquids. It says how difficult it is for liquids to enter the enclosure. It doesn't say that it's impossible, but it sets up some criterions on how to, what they should withstand. For example, our housing is certified to IP67. That means that for water or liquid, it has to be at a depth of at least 1 meter for more than 30 minutes without any ingress of water. If it takes 31 minutes and there's a drop, we still have passed it, but well, I can assure you it's better than that. But that are the limitations that there. And 8 is a variable level where you as a designer set how deep or which pressure and how long. And if you're on an oil rig or deep sea, then of course you want to specify that. And then we have 9K, which is for wash down in food industry and so on. The IP rating, it's a certified rating. So we use a UCAS approved third party to certify this. So if someone says it's IP rated, the housing, there has to be certified, as a certificate for that, and we have a certificate for that. So here are pictures from our certification process, and to test the solids, they actually drill a hole in the housing and put vacuum in it, and then there's a dust chamber where there's just a lot of dust, and for a certain amount of time there is an under pressure in the camera housing, and when this is done, they open it up and verify that there's no dust inside. And for the 7 rating, which is for the liquid, they dunk it down in a tank 1 meter deep, well anchored down there, and after half an hour they take it out and they check that it's dry. And these are then witnessed by 3 people, all signing all papers and so on. So it's all according to standards. We have a mixed rating, which is or X-rated 6X or X6, which is basically says that it just guarantees one or the other. With an IP rating, there is no requirement on robustness. So you can have something that is quite thin and flimsy almost, and it still is IP67 or IP68. And so it doesn't give you anything about robustness. Robustness for us, that comes from the body material and the lens tube material. And but just think about that when you see equipment that's 67 or 68 rated, it doesn't say anything about robustness. The other thing, in the US, they use a NEMA rating. There, of course, it's slightly different. It is a self-certified standard, and you can opt for a third-party verification. So you can just say that it's NEMA 4 or NEMA 6 and certify that yourself. Then we come to EX rating, and this is a big thing with a lot of legalities and so on. So we have 3 levels there. Explosion containment. Basically, they take the camera housing, make an explosion inside, and see if it holds. Explosion prevention. Then the camera housing is purged from gases and other stuff, and so there can be no explosion or fire with an open flame. And then the last one is intrinsically safe. That is a chain of limitations on the equipment, like how much power they can use. So any faults in the equipment shall not produce any warm heat enough to ignite the media around it, surrounding it. All the levels for this, it's a mess. Then there is something called the IK rating, which measures how much impact an equipment can take, an enclosure can take. And it actually measures in joule, how much energy it can take without breaking. And the maximum is IK10, which corresponds to dropping an item from 5 kilos from 400 millimeters onto the enclosure. Currently, our housings are not EX or IK rated. So when we decide this, we also have a lot of choices when it comes to materials and what options to use. For the body, of course, robustness is really important. Heat transfer, all GE cameras today, they generate a lot of heat. So we need to transfer that away. So solid aluminium with good contact with the camera is very important here. Manufacturability is another thing when it comes to keep the cost down. Weights for robot applications, weight is probably more important than fixed ones. The lens tube, we have the same thing, robustness and manufacturability. So in our standard series, we have an aluminium tube which is fully modular with a thread on the front where we can mount accessories. But for cost and also a very, very good impact resistance, we use nylon tubes too, nylon 66, and it's chemically stable and UL and all UV stable and so on, so it can be used outside. Ceilings is another thing. We have chosen EPDM as a standard. It's a good sort of middle way, but it's not that good with some petroleum product and solvents. And then we can go to silicone, which is of course in food industry. We have FDA approved silicone and so on. But there's a number of different gasket materials that we offer if needed, if you have really bad environment. We also opted for flat gasket to facilitate easy inspection of the gasket and see that it's there, and also make it insensitive to some damage of the surface. We still have a sealing even if the parts are slightly damaged. Cable glands and connectivity. So we chose a cable gland where we can actually use already fitted cables. So the cable glands are split. We also have an option where the full gland is split, so we can have them maximize the connector size that goes in. We also offer it with M12, M8 connectors on there. One thing with M12, M8 connectors is that what you do there is you introduce a reflection point in the transmission, signal transmission, which can reduce the bandwidth of, for example, GE cameras. Glass again, there's so many. We went for a BK7 glass, which is a high quality flat glass, good transmissivity. We also offer sapphire glass, which is really hard and dirt is difficult fitting on it. For thermal cameras like the new Basler camera, we will have a germanium glass with a diamond-like coating. It's called DLC coating. And for food and other, we can have acrylic too. Coatings, we have a one-sided AR coating on the inside because that's where it's most important. This leaves us the outside with pure glass, which makes it scratch resistive. So when you're out there, the glass is always harder than most anti-reflective coatings, even with hardening. But we can offer any coating on these glasses. So we have a few items here, which is moisture. Moisture kills. And one of the things, assembly environment is important there, and temperature stability, management of temperature, because it's a difference in temperatures that creates condensation, which is killing us. So when our equipment is colder than the air, and it's colder than the dew point, we will have condensation. So there's a lot of prevention ways there. We can have silica bags or machined polymer solids, depending on vibration level. So one tip is just those silica bags that you get with lenses, just put it in the back of the camera housing. If it's not vibrating, it will work absolutely fine, and it will take that away. We also have breather wells, valves, Gore-Tex valves that can be fitted, and they're available small enough so they can be fitted on our small houses. When it comes to dirt, avoid it if possible, but there's a reason we have the camera housings. But if we can mount the houses as far away from the major source of dirt as possible, and Another tip here, angle the cameras down. That solves a lot of problem, just the angle down. So because gravity works on the dirt and it falls down, and it will help in preventing dirt. So this is something that we have in northern Sweden. So this is motorcycle ordinances, driving full speed on snowways in the cold, and there's actually motorcycles with skis on them. They're very agile on the snow. So what does this have to do with camera housings? And you ask again, what does this have to do with camera housing? What they used in the back in the days was this funnel in front of the face. It creates a cushion, a bumper for air, and keeps your face warm. And one easy thing to prevent dirt is to use tubes and shields, or funnels and shields. And in our case, we can mount one at the front of the camera lens to keep it free from dirt, or use a sun shield. Active dirt prevention maintenance, of course, clean it, wet clean. You can't believe what they do in certain industries. They take anything, an oil or rag, and try to clean it. So wet dry cleaning is something we have to try to clean, tell them. We have air rings to use for cleaning. Sometimes, if they're wrongly designed, they actually pull particles from the air and deposit them on the glass rather than keeping them off. So be very careful with the design of this. A better way is air knives using the Coanda effect and laminar flow to keep it clean. Shutter is another way where we can have a mechanical shutter in front of the glass. Wipers and water spray are other things. These are very, we will not go there. As in IP Elements, these are quite specialized and more outdoor use. Temperature management. This is very important. It can't be too cold and it can't be too warm. And we have the laws of thermodynamics that rules this. So we have different modes of conducting the heat. So conduction, convection, and radiation. So best, of course, again, is passive management. So we put in a position. Where can we put it? So if you're measuring hot steel slab, stay away as far as you can, or actually anchor it to a cold structure. Again, we have the shields. So a sun shield with a distance creates a bridge between the radiation source and the actual body of the camera. So to reduce the warming from there. We have active, which is water cooling or air cooling. Again, caution about too cold water. It makes the body too cold and we create condensation, which we don't want. We have heating, which could be, in our case, will be a ring at the front on the lens tube. Other, they mount it directly onto the glass. So here we have the set of considerations when it comes to implementation of machine vision systems in dirty environments. And we will sort of continue to develop new accessories to make it easier and to work with machine vision systems in dirt environment. So in our roadmap, except for the stainless steel, which is fairly easy to do, we're also going to make it so it fulfills FDA and food standards, which is about traceability and so on. We're coming out with a medium and large size houses for larger cameras based on the same principle. We're also working with the ATEX, which is a long process because not only is the certification, but also construction and so on, documentation. We have the popular dart camera, and putting one of these big housings from us is maybe not ideal there when it comes to cost and space. So we're working on a solution for the dart cameras. And for accessories, we have the air knives, washing and shutters, and mounting, there will also be a swivel link adapter. So more with the enclosures, we can do customizations. We have here an example where a customer use very large lenses at the front. So we can provide them with a housing that has a larger front tube, using the same principle, just a larger front tube to fit these large sensor lenses. And if you have customers and volumes, we can adapt colors and laser engraves and so on. We also do bespoke solutions for encapsulation for special cameras or integrated systems, where we put a lot of equipment in same, where you need precision machining for calibration and so on. And so this is part what we also provide. So thank you for your time, and I hope you learned something new from this. Thank you very much.